Welcome to Med TV. Today we are going to explore how to solve a dilution problem using concentration calculation. Now let's dive right in. So in our first problem we have how many milliliters of water must be added to 50 ml of 10% weight volume sodium chloride solution to make it 5% weight volume sodium chloride solution. So when you are given this type of question, the first thing that we need to do is to get to understand the problem. So we need to dilute 10% sodium chloride solution to make it a 5% solution. So this means that we will have the concentration. So we will need to double the volume. So the first step that we need to do is calculate the amount of sodium chloride in the original solution. So the original concentration is 10%. The original concentration is 10%, which means 10 grams of sodium chloride per 100 ml of solution. So in 50 ml, the amount of NaCl will be equal to the volume times the conc. That's the concentration, which will be 50 ml multiplying 0.1. Then it will give you 5 grams. Very simple. So the step 2 is to determine the final volume to have the same amount of NaCl in 5% solution. So our final volume will be, so that will be our final volume multiplying 0.05, which will give us 5 grams, right? Now, so we need to find our final volume. So we have to just make the final volume the subject. So making the final volume the subject. So go to the next page. So making the final volume the subject. So final volume should be equal to 0. Should be equal to, that will be 5 grams on 0.05, which will give you 100 ml. So the last step that we need to do is calculate the volume of water to be added. So the initial volume is 50. We know that the initial volume is 50 ml, and the final volume needs to be 100. And the final needs to be 100. Right, so volume of water added. So volume of water added will be equal to the final volume minus initial volume. And when you do it, we have 100 ml minus 50 ml. And when you do it, you should get 50 ml. So you need to add 50 ml of water to the solution to achieve the desired concentration. Simply write. Very, very simple. Now, our next problem, we are going to look at how to make solution of different concentration to achieve a desired final concentration. So we have a problem. So we have how many milliliters of 20% weight volume alcohol solution should be mixed with 60 ml of a 10% weight volume alcohol solution to obtain a 15% weight volume alcohol solution. So let's set up the problem. Now we need to find the volume of the 20% alcohol solution that when mixed with 60 ml of the 10% solution, we will get 15% solution. So the first step that we need to do, here is to set up the equation. So let's x, right, be the volume of the 20%, be the volume of the 20% alcohol solution. Right, very simple. And the total volume of the final mixture will be. So the total volume should be. So let me clean this one here. So the total volume of the final mixture should be X plus 60 ml. Now, in our next step, we need to calculate the amount of alcohol in each solution. So, for 20%, for the 20% solution, alcohol here is equal to 0.2x grams. Now, for the 10% solution, alcohol is 0.1 times 60 grams, which when you do it, you should get 6 grams, right? Now, in our next step, we are going to form the equation for the final concentration. So the total amount of alcohol in the mixture is the sum of the alcohol from both solutions, and the concentration in the final volume should be 15%. So with that being said, we are going to have our equation to be 0.2x plus 6 should be equal to 0.15, open bracket, x plus 60. Now we solve for x. Solving for x, we are going to get 0.2x plus 6 should be equal to 0.15x plus 9. Group like terms, get 0.2x minus 0.15x should be equal to 9 minus 6. Then we have 0.05x equal to 3. Then x should be equal to 3 on 0.05. Then our final answer should be 60 ml. So you need to make 60 ml of the 20% alcohol solution with 60 ml of the 10% alcohol solution to get the desired 15% concentration. Now, problem is solved. Very, very easy. Now, in our next example, here we are just going to solve some problem involving concentration changes due to evaporation. So we have a problem. 100 ml solution contains 5 grams of sugar. Now, if 20 ml of water evaporates from the solution, what would be the new concentration of the solution in percentage weight over volume? Very simple. Now, just understand the question, then the solution volume. You have to understand the question first. After understand the question, you can see that the solution volume decreases due to evaporation, but the amount of solute, that's the sugar, remains the same. It does not change. Now, after that, what you need to do is to calculate the new volume. So, our new volume here, new volume, should be equal to 100 ml minus 20 ml. So, the 20 is what was evaporated. This is the total amount. The 100 ml is the total amount of fluid that we have. So when we do it, we should get 80 ml after the evaporation. Now we calculate the concentration. Now concentration is defined as the amount of solid divided by the volume of the solution. So concentration is equal to the amount of solute over volume of solution. So 5 grams on 80 ml multiplying 100 because we want it in percentage. So when we do it, we should get 6.25%. So the new concentration of the solution is 6.25% weight on volume. That's very straightforward. It's not really, really hard to do. So So in our next problem, we are just going to look at how to prepare specific volume and concentration of a solution. So we have the problem. How you prepare 200 ml of 0.5 molar sodium chloride solution using the solid sodium chloride. So the first thing that you need to understand always is to understand the question. Now we need to prepare a solution with specified molarity and then a volume. Now the second step is to calculate the amount of NaCl needed. Now the molarity is defined as the moles of solute per liters of solution. So we will need 0. So let me change the color here. We need 0.5 moles per liters, and we need 200 ml. So 200 ml, which is the same as 0.2 liters of solution. So when you are done with this, so the moles of NaCl should be equal to 0.5 molar times 0.2, and this answer should be equal to 0.1 moles. Now we then convert the moles to grams. So the molar mass of NaCl is approximately 58.44. So the molar mass of NaCl is 58.44 grams per mole. And so the mass of NaCl should be equal to 0.1 moles times the 58.44 grams per mole. So the mole here cancel with the mole here, and we should get 5.844 grams. So we have to prepare the solution. Then we measure 5.844 grams of NaCl. Then we dissolve it in enough water to make the final volume of 200. Now, to prepare 200 ml of 0.5 molar NaCl solution, just dissolve the 5.844 grams of NaCl in water to make up the final volume. Easy to follow. Thank you for watching this video, and I will see you in my next video. Bye.